Alright, so this packet is kind of thick. I don't feel too bad about that because I haven't given you any flip work for a while. So let's get through this. Bunch of new vocab. We'll skip the warm-up and we'll skip lesson objective. Vocab, equidistant. When a point is the same distance from two or more objects. So if I'm standing, at the 50-yard line on the football field, then each of the end zones is equidistant from me. Same distance away from where I'm standing. Locus, a set of points that satisfies a given condition. We'll talk about that more in class. Okay, perpendicular bisector theorem. So if I have a perpendicular bisector, so I look at this picture, there's line L, it's perpendicular to segment AB, and notice it bisects, it cuts AB in two equal pieces, then line L, we call that the perpendicular bisector. And what we need to know about that is if L is a perpendicular bisector, then any point that lies on line L is the same distance to A that it is to B. So any point that lies on the perpendicular bisector is the same distance to A that it is to B. So my conclusion would be, again, if I know that XY is perpendicular to AB, and I know that YA is congruent to YB because I have a perpendicular bisector, my conclusion will be that XA congruent to XB. And the next one just goes in the other direction. So now I'm looking at my picture. I see that I have line L intersecting segment AB, but I notice that XA is the same length as XB. So now we can work backwards. If I know XA is equal to XB, then I know that line L must be a perpendicular bisector. So XY must be perpendicular to AB, and YA must be congruent to YB. Okay, so how does that work? Just some easier little problems to look over and talk about. So it gives us this picture. It says find the length of YW. Well, here is YW. But I look at my picture, I see that line L is perpendicular to segment XY, and I see that XZ is congruent to YZ, so that means that line L is a perpendicular bisector, and that every point that lies on line L is the same distance to X as it is to Y. So if I know that WX is 7.3, then YW must also be 7.3. Okay, I look at this picture. And again, if you want to look at these beforehand, try pausing the video and try getting ahead of me. That would benefit you greatly. So I look at this picture. I don't know that I have a perpendicular bisector looking at it right away, but I notice the distance from A to B is the same as it is from A to C. And we just said on the last page that if these two distances are the same, then line L must be a perpendicular bisector. We know it's perpendicular, so that means BD must be congruent to CD. Well, if BD is equal to 16 also, then BC, what we're trying to find all the way across, must be equal to 32. All right, another one. This one they want to know about PR. I look at the picture. I see that line L is perpendicular to PQ. It also bisects PQ, so it's a perpendicular bisector, which means every length from R to P must be congruent to also R to Q. So that's what I set up. I set 2n plus 9 equal to 7, 9 minus 18. I subtract 2n from both sides, which gives me 9 equals 5n minus 18. I add 18 to both sides, and I get 27 equals 5n. So n equals 27 over 5. But they wanted to know what PR was. Well, I already know what PR is, how to represent it. It's 2n plus 9. So PR equals 2n plus 9, but I know that n is 27 over 5, and I'm just going to leave it like that. So PR equals 2 times 27 over 5 plus 9. Okay, so that is perpendicular bisectors. There's a few more examples. Slide over, show the picture. So they're telling me that L is the perpendicular bisector of DE. So L, perpendicular bisector of DE, and EG is 14.6. So from G to E is 14.6, and they want to know how far it is from G to D. But if this is a perpendicular bisector, remember, every length from G to E, every length from point L to E must be the same as from point L to line D. So if GE is 14.6, then GD must also be 14.6. And then they tell us that same picture, different setup. DE is 20.8. So DE is 20.8 all the way across. DG 36.4 and EG 36.4. Well, if these are the same and this is perpendicular, then L must be a perpendicular bisector. And I want to know how long EF is. But I already know how long DE is, and DE is all the way across. But if we know L is a bisector, then how long must EF be? Half of DE. So EF must be 10.4. Okay, so that was perpendicular bisectors. Now let's talk about angle bisectors. So in this picture, I know that APC is congruent to BPC because they each have an arc. So that means PC must be an angle bisector. So what we need to know from this picture is that if I go from point C anywhere on this ray, anywhere on this angle bisector, perpendicular to this ray and perpendicular to this ray, that these two lengths are going to be the same. So AC equals BC. So if I have an angle bisector, if I go from any point on that bisector perpendicularly to this ray and to this ray, it's the same length. And then of course we flip it around and we look at this picture and we say, well, AC is congruent to BC because they each have a tick mark. So therefore, if these are the same, then I can conclude that APC must be congruent to BPC and PC must be the bisector. So these are just going two different directions. Okay, so what does that look like? I've got a picture that looks like this. It says the measure of angle ABD. Oh, I'm trying to find that, sorry. We're trying to find the measure of angle ABD given that ABC is 112. So ABC is the big angle. It's 112 degrees. But I look at my picture, I see that these two lengths are the same, which means that BD must be a bisector. And I'm trying to find ABD. Well, ABD is just that little angle. But if BD is a bisector, then these two angles must be the same. And if they add up to 112, I can just do 112 divided by 2 and get 56. So the measure of ABD is 56, and the measure of angle CBD is also 56 because I have an angle bisector, and I know that because these two sides are the same. Okay? This one, they're trying to find the measure of angle TSU. Trying to find the measure of angle TSU, we're given this picture. Well, I look, again, I see tick marks on these two sides, which tells me that this must be an angle bisector. Well, if that's an angle bisector, then these two angles must be congruent to each other. So 5z plus 23 must be equal to 6z plus 14, which is what I set up over here. I solved for z and I got 9. I plugged the 9 back in because, again, I'm trying to get the measure of TSU, and TSU is equal to 5z plus 23. I put the 9 in for the z and I get 68 degrees. All right, this next one, again, do me a favor, pause it. Pause it, look at it yourself, see if you can figure it out, and then replay the video and see if you get what I got. Alright, we're told that YW bisects angle XYZ, and we're told that WZ, this length right here, is 3.05, and we want to know what WX is. Well, remember, if it's an angle bisector, these two lengths have to be the same. So if that's 3.05, this must be 3.05 also. Okay, moving right along. We'll skip the objective here. Concurrent. It's when 3 or more lines intersect at one point. So if I draw 3 lines, or 4, or 5, 6, 7, whatever, that if they all touch, that point where they all meet, that's called concurrent. And that point where they all meet is called the point of concurrency. So the point of concurrency is just the point where all the lines meet. Okay, circumcenter of a triangle. So this is we're getting into some newer stuff here. Circumcenter of a triangle. It is the point of concurrency of the three perpendicular bisectors of a triangle. So if I draw in the three perpendicular bisectors of the triangle, the point where they all meet is what we call the circumcenter. And if I circumscribe something, it just means that every vertex of the polygon, in this case a triangle, lies on the circle. Okay, so let's turn this into a picture. So again, the circumcenter is the point where all three angle bisectors of a triangle touch. So here's my triangle. There's triangle ABC. Notice this segment straight up and down, it bisects segment AC because of the tick marks, and it's perpendicular. So this is a perpendicular bisector of AC. This line over here bisects BA and it's perpendicular to it. So this line, this segment, is a perpendicular bisector of BA. And this one coming this direction is a perpendicular bisector of BC. And that, so you draw in all three perpendicular bisectors, and that point that they touch, that point of concurrency, is called the circumcenter. And notice how the three vertices of this triangle are sitting on this circle. That's what it means to be circumscribed. This triangle is circumscribed in the circle. Something we need to know, if I do my circumcenter and I go from my circumcenter to every vertex, so if I go from point P to A, point P to C, and point P to B, they are all congruent to each other. That's important. More to follow in class. Circumcenters do not have to be inside the triangle. If it's an acute triangle, the circumcenter will be inside the triangle. If it's an obtuse triangle, the circumcenter is going to be outside the triangle. If it's a right triangle, the circumcenter is going to be on the triangle itself. Okay, right triangles are easy. Let's do one real quick. It says find the circumcenter of triangle RSO with vertices. So R is at -5, 0, S is at 1, 4, and O is at 1, 0. So I just plot the points. There's R, there's S, and there's O. And they want to know where the circumcenter is. Again, to give you a right triangle, that's very easy to do. Because I have this side of the triangle. I need to draw in a line that bisects it and is perpendicular to it. Well, this is 1, 2, 3, 4, 5, 6 units long. So if I'm going to bisect it, 6 divided by 2 is 3. So I count 3 over, 1, 2, 3. And this is a horizontal line. So if I draw a vertical line, this line right here is a perpendicular bisector of side RO. Then I can do the same thing to SO. This is 4 high. Half of 4 is 2. So I go right in the middle and I go this way. And where these two lines touch, notice it's right on the triangle like we just said up here. And so my circumcenter is at -2, 2. That is where my three perpendicular bisectors will touch. That's called the circumcenter. All right, one more quick page of notes. Incenter of a triangle. This is the point of concurrency of the three angle bisectors of a triangle. So if I draw in the three angle bisectors of the triangle where they all touch, that's called the incenter. And an inscribed circle is a circle in which each side of the polygon, in this case a triangle, is tangent to the circle. Tangent means it just hits it in one spot. Okay, so they've done the incenters here. Notice they've drawn in angle bisectors. These two angles are congruent, so that's an angle bisector. These two angles are congruent, so that's a bisector. And these two angles are congruent, so that's an angle bisector. So they drew them all in, and where they touch, that's called the incenter. What we got to see here is, notice, for the circumcenter, it was the same distance from the circumcenter to the vertexes that were congruent. That's different about the incenter. The incenter, if I go from the incenter to the sides of the triangle, those are all congruent. Unlike the circumcenter, the incenter is always inside the triangle. That is important. Okay, so how do we use this stuff? City of Odessa will host a fireworks display for the next 4th of July celebration. Draw a sketch to show where the display could be positioned so that it is the same distance from all three viewing locations. Justify your sketch. Okay, I'll have you all work an example like this in class, but here's how we're going to do it. So I'm taking this stuff, it's called patty paper. I'm going to position it up so I have it like that. There's my triangle. So I'm trying to put something that is the same distance from all three of these things. So what is that called when I want, is that the circumcenter or the incenter? Which one of those is the same distance from the vertices of the triangle? That's the circumcenter. So all I have to do is draw in or find a way to represent the three perpendicular bisectors. And where they touch, that's called the circumcenter, and that is where I want to put my display. And so that point down here at the bottom where they touch, that is where my three perpendicular bisectors touched. That would be my answer. We'll do more of these in class.